Kia ora Year 12 and 13. This video is a revision video for my A-level class going over some of the Delta work. So my A-level class have got the old Delta books, so this is Delta chapter 6.1, but if you're watching this and you're in level 3 calculus, it's in the new Delta book and it's in 1501. I haven't used exactly their questions, but what I've done is picked out some of the harder ones and I'm going to be doing this for each exercise. So I'm starting off with some basic polynomial differentiation. These questions are really good practice at making sure you can deal with fractional and negative powers easily. So these are the 5 questions that I'm going to do. What you should do here is pause the video and have a go at them yourselves. The clue though is that in every case you need to do some simplifying before you do any calculus. Okay, so I'm going to make this a bit bigger so that we can work through them on the one screen. So the first one I need to rewrite with fractional and negative powers. So y is equal to x to the power of 1/5 plus 13 x to the power of negative 2. And once we've done that, we're good to go. We can differentiate using the rules that we had back in year 12. They work in exactly the same way. So here I'm bringing down this power and I'm multiplying it by 13. So I get minus 26x to the negative 3. Now it's fine to leave it like that, but it would be nicer if we put it back into third form. So I'm going to do that now. This is going to be 1 over 5 times x to the power of 4/5 minus 26 over x cubed. Okay, so that's that first one done. Now this next one looks awful until we spot that we've just got one term in the denominator. So what does that mean? Well, I'm just going to take some space and do this one down here. If you think about, suppose that I have y equals 8 plus 4 divided by 2, then that's the same as 8 divided by 4 plus 4 divided by 2. Sorry, 8 divided by 2 plus 4 divided by 2. The same thing works with variables. So if y is equal to this, then I can split this up. So this is, I'm going to do this one slowly. And split this up like this. And it is worth doing this slowly because it's very easy to make mistakes with the coefficients. So in here, 3 over 6 is just 1/2. I'm going to have x cubed, and I like to put the 1/2 out the front like that. It's harder to muck up if we do it like that. Okay, so 1/6 x squared plus 1/3, and I'm going to write this as x to the power of negative 1 because I know that I'm differentiating. So it's easier to have negative power than 1 over x, which is what I would have in here. So this is 1 over 3x. Right, so now we differentiate, and you can see the hard part of that question was in the simplification. So we're going to bring down the power. 3 times 1/2 gives me 3 over 2. 3 over 2x squared minus 2 times 1/6, and then I bring down the power, so that's x to the power of 1, plus, and then I'm going to have negative 1 over 3, x to the negative 2, and you can see that still needs a bit of cleaning up, right, because I haven't simplified this fraction, and I've got plus and negative here, which just looks a bit silly. So we've got 3 over 2x squared minus 1/3 x minus 1 over 3x squared. Okay, on to number 3. Right, so number 3 is pretty easy. We could do this using the product rule, which A-level people we've learned, but I wouldn't bother. It's much more simple just to expand this out. So when I expand it out, we'll get negative 7 over 2 x to the power of 6 plus 7 over 2 x. Okay, so now we can differentiate. Dy by dx is equal to negative 42 over 2. Right, so pulling down the power, timesing it by the coefficient, x to the power of 5 plus 7 over 2. And that equals negative 21 x to the power of 5 plus 7 over 2. Right, now this next one is one where we've got a negative power and a fractional power. So f of x is equal to 49 over this. So that's 49x to the power of negative 2/3. Now we're ready to differentiate. So it's going to be 49 times negative 2/3 x to the power of negative 5/3. Right, I'm dropping this power by 1 and I'm multiplying the negative 2/3 by the 49. Cleaning that up gives me negative 98 over 3 x to the negative 5/3. Now if you're sitting in NCEA level 3, you'd get a tick for that, right, if you were lucky enough to get that question. But it's nicer to write it as back how we started. So it's going to look like this. There we go. That's a 5, not a 6. So there it is. Right, and the last one is another fractional powers one. So rewriting f of x, we get negative 7x to the power of negative 9 over 5. Now we can differentiate. F dash of x will be 63 over 5, right, so I'm bringing down the power and multiplying it by the coefficient. X to the power of negative 14 over 5. Again, it would be nice if we could clean that up and write it like this, 63 over 5. And it's the 5th root of x to the power of 14. So that's a nicer way to do that. So there you go, just some quick revision. What some of you might find from this is that actually you're not having trouble with the calculus, you're having trouble with the fractional and negative powers. And if that's the case, then Level 2 Education Perfect is good, or the Theta textbook is also good. Thanks for watching. I will be back with some more revision ones later on. If you're in my A-level class, I'm going to do the next one I do is going to be on implicit differentiation.